Hello class, this is the bond valuation PowerPoint that I tried to record in class and the mic didn't work. I'll do it here. Make sure you review this PowerPoint 2, 3, 4 times until you understand how to find the price of a bond. Historically, it's a confusing chapter for the students because you have never seen a bond, you have never purchased a bond, so it can be difficult. But if you watch the video enough times, go over the PowerPoint in Blackboard, read it in your book. If you don't have the book, you can use any finance book. They have these concepts. So we saw in class that bonds are issued by governments and companies when they want to raise money. Remember, companies can raise funds internally, it's called retained earnings, or externally via equity or debt. When they do that, it can be a commercial loan or they can sell bonds in the market. When you buy a bond, you're giving the seller a loan, the company or the government, and they agree to pay you back the face value or par value at the end of the life of the bond. They will most of the time pay you the coupon payment, which is the periodic interest rate, a payment, usually twice a year, or semi-annual bonds as we saw today in class at the end. This is a corporate bond. It's McDonald's. Face value, par value, 1,000. Coupon rate is 4.25. In the exam, I'll give you 4.25 or 6.25. I won't give you fractions. So you have to know how to do this. I will not give you the equation in the exam. The coupon payment is the coupon rate times the par value. So 1,000 times 0.0425 equals 42.5. We don't know what is the maturity, so this will happen until the bond expires. This is a government bond, face value 1 million, the coupon rate 7.58%. So the coupon payment will be the par value, which is 1 million, times the coupon rate, which is 0.07625. 5/8 is 625. So the coupon payment will be 76,250. So this is a bond with a very large coupon payment, but also the face value, it's very large. This is likely to be a very expensive bond. In class, we'll use 1,000. However, in the homework, my finance lab, sometimes they change the par value to 10,000 or 5,000 or 500. So if you have to calculate a coupon payment in a bond with a face value other than $1,000, you still follow the same equation. But instead of using par value 1,000, you use 1 million or 1,000, 500, etc. So let's do one bond. It's a 6.5% coupon bond. It makes annual payments, 5 years until maturity, par value 1,000, and similar bonds pay 8%. So the price will be N equals 5 payments, 1 per year. The IY is the 8% or YTM or required rate. You're looking for the present value. The payment is $1,000 par value times coupon rate 6.5% equals 65, and future value always 1,000. Some students find the payment by multiplying the bond price times the coupon rate. Some students multiply the face value times the rate, like in this case 8%, and they use 80. Be careful not to make that mistake. So in this calculator, let's do second clear TVM. If you only have 2 decimals, remember, you do second decimal to access the format menu. And if you see the following on your screen, decimals 2, you need 4 at least. So you enter 4, press enter, and then second quit. Now you have 4 decimals. So N equals 5, so we 5 N 8 IY. You're looking for present value. Payment is 65, and the future value is 1,000. Compute present value. So the bond price will be 940. And the negative, all it means is you're buying the bond from the company. Okay. In the other calculator, you do apps, finance, TVM solver, option 1. So N equals 5, I% equals 6.5, payment 65, no, I% equals 8, future value 1000, and make sure you have PY equals 1 and CY equals 1. If you have a different number, it'll give you the wrong answer. And then alpha, enter, and there is your 940. Same result. In this calculator, if you're getting the wrong number, it is also because you have the PY equal to other number than 1. So here's the PY above the IY. To access that, do second IY, and if you see PY, let's say 12, like that, then you have to make it 1 by doing 1, enter, and then second quit. Now you can compute present value and you'll get the right answer. So visually, what is happening here? This is the timeline of the bond. It's 5 years until maturity, okay? And the bond makes payments of 65 once per year, which are the coupon payments, and then we have the par value 1000, which is paid at the very end of the bond. So the value, the price of a bond, in fact the value of anything, is equal to the present value of the expected cash flows. Once you have all the present values, you find the sum of all of them and it'll give you the value of an asset. In this case is the bond. Now, specifically for a bond, the bond's expected cash flows are an annuity, which are the coupon payments, 65 every year, and a lump sum par value 1000. When you're using your calculators, here the payment button 65, that's the annuity. And how many of those 65 you have? 5 of them. And then the lump sum, the future value, it's right here, the 1000. How many times are you going to discount that lump sum? 5 periods. Okay? So the calculator is taking the annuity of 65 and then the lump sum of 1000, discount all of that 5 periods, and then it combines everything into a single price, which in this case is 940. Okay? So that's how you find the price of a bond. What is the effect of rates on bond prices? Assume that immediately after you buy the bond, rates fall to 6%. They used to be 8. So it's immediately after, so n equals 5 still. IY is now 6%. The payment still 65. Par value never changes, 1000. So since we already have the numbers in the calculator, all I have to do is change the IY to 6, so 6, IY, compute present value. So it's 1021, the new price. Okay, so when rates fell from 8 to 6%, the bond price went from 940 to 1021. In this calculator, I% equals 6, present value, alpha, enter, 1021. Now, let's go the other way. The rates go up from 8% to 9% immediately after. So n equals 5, IY 9, payment 65, future value 1000. So let's make 9 IY, compute present value, price 902. And the other calculator, so let's make I% 9, go to present value, alpha, solve, 902. Okay. So when rates went up, bond prices fell. And this one, rates fall from 8% to 6.5%, and the coupon rate on this bond is also 6.5%. So what's going to happen? When the YTM, or the rate, or the discount rate, in this case 6.5%, is exactly equal to the coupon rate, which is 6.5 as well, right here, the bond price will be 1000. For instance, here 6.5 IY, compute present value, see, exactly 1000. In this calculator, 6.5 alpha, solve, 1000. Okay. So we can conclude the following. that when rates fall, bond prices rise, and when rates rise, bond prices fall. Okay? So there's an inverse relationship between YTM, or rate, discount rate, required rate, any way you want to call the interest rate, and bond prices. They move in the opposite direction. And also you can see that when R equals the coupon rate, then the price of the bond is equal to par value, meaning it sells for 1,000, and we call this bond par value. When R equals, it's less than the coupon rate, then the bond price will be greater than par value, meaning more than 1,000, and we call this bond's premium. And when the R is greater than the coupon rate, the bond price will be less than par value or less than 1,000, and we call this bond's discount. Now, YTM. If you buy a bond and you hold it for the number of years until maturity, and it can be 90 days in government bonds, 90 days all the way to 30 years, and in corporate bonds it can be any number. As I mentioned in class, Disney has a 100-year bond. So if you hold it until the very, very last day, then you can calculate your annual rate of return, and we call that yield to maturity. Okay? So let's calculate that. You purchase a bond for $850, coupon rate is 8.75. The bond has 10 years. What is the YTM of the bond? Now it's a discount bond because it's less than 1,000. Coupon rate is 8.5. So the YTM you estimate has to be less than the coupon rate so that the bond can sell for a discount. You can see right here. For a discount bond, the YTM R has to be greater than the coupon rate. Okay? It's one way to check if you're doing your calculations right. So we have 10 years. I'm looking for the IY, which is the YTM. Present value will be negative 850. In class I use a different number, but I want to use this right now. Payment coupon is 0.075 times 1,000 equals 87.50. Future value 1,000. So the YTM will be, so do new bond, so second clear TVM, 10 years, 850. Negative, you're paying for the bond. Present value 87.50. Positive, you receive the coupon payment. Par value 1,000. Positive, you receive the par value. Compute IY. So the YTM is 11.33%. So if you hold this bond for 10 years, receive the coupon payments of 87.50 and the par value of 1,000, and you pay for this bond 850 on an annual basis for 10 years, you will be earning 11.33%. Don't forget, we express yields on an annual basis so we can compare investments with different maturities. Okay. In this calculator, so N equals 10, present value 850, payment 87.50, alpha 11.33%, same as the other calculator. And same table, but instead of using R less, equal, greater than coupon rate, I'm using YTM, which is how you express bond yields, as YTM. Okay. Let's do this. In class, I mentioned, what is your total 10-year return in this investment? Well, if you hold the bond for 10 years times 87.50 and then plus the $1,000 you paid for you receiving face value minus 850, which is what you pay for the bond, then your total 10-year dollar return will be equal to $875 plus 1,000 minus 850. You will be earning in dollars 1,025. Okay. And then if you divide your total dollar return 1,025 by what you paid for this bond, which is 850, this is equal to 1.21, which equals 121%. That's total 10 years. If you want to find an annual average yield, let's divide this by 10 years, and that will be equal to 12.1%. Okay, that's an average yield, but again, that's assuming simple interest. Look at your real yield on the investment. It's only 11.33 because this one assumes compounding. Okay, in class, because of the numbers I use, these two numbers were almost the same, but you can see that we can make the numbers to be far apart with a different bond price. Anyway, zero coupon bonds, they do not pay a coupon payment. The coupon rate is 0%. They always sell for a discount. It's the only way you can make money. A coupon paying bond, you can pay a premium and still make money because you receive the coupon payments. So in this one, a 5-year will be 5. The IY is 7.5. The payment 0. You have to input payment 0. Future value is still 1,000. So the value of this bond will be new bond. So clear the TVM 5N 7.5 IY. Payment 0. Future value 1,000. Compute. So you'll pay for this bond $696. Which is a discount. And in the other calculator, 5 years, IY 7.5, payment 0. Future value 1,000, present value alpha. Okay, so 696. And then in class, we mentioned that over time the par value will remain constant. We mentioned in class that the par value will remain constant, 1,000, but bond prices fluctuate. And there's a couple of reasons why they fluctuate. Either you have less time until maturity. Okay, the end is 5 and then 4 and then 3, 1, 0, or the I%, the YTM can change. When conditions in the economy change, rates will also change, which is going to affect your present value. The payment, in this case, it's 0. It's a 0 coupon bond, but that one doesn't change. And the future value, it's also not going to change. It's 1,000. Okay, it's like this bond we have on the screen. You can see that the face value is 100 and it's on the bond. It doesn't change. So what happens if the following year, if we assume that rates in the economy will be 7.5% the following year, now the bond only has 4 years until maturity, so the present value will be 748. 2 years later, only 3 years left in the bond. So the price will be 804. When you only have 2 years left until maturity, present value will be 865. We only have 1 year until maturity, 9/30. Okay. And on the day the bond matures, n equals 0, calculate present value, 1,000. So you can see that the bond price is slowly approaching par value, which is 1,000. In a zero coupon, the price will always be below par value. In a coupon paying bond, you can do the same, but the price can sometimes be above or below 1,000, or it may be equal to 1,000 because of the coupon payment. But on the day the bond matures, the price will be 1,000. Semi-annual coupon bonds. This is find the price of a 10% semi-annual coupon, 30 years, YTM 8%. So N equals the following: 30 years times 2 payments per year equals 60 payments left. 8% is annual. To make it semi-annual, divided by 2 equals 4. Payment, it is a 10% coupon bond times 1,000 equals 100. That's the annual coupon payment. In semi-annual payments, you will receive a payment every 6 months of 50. Future value doesn't change in a semi-annual, still 1,000. So the present value will be new bond, so 60 and IY4, payment 50, 1,000, compute present value, so it will be 1,226. So this is a premium bond, and it makes sense because the coupon rate is 10%, YTM 8%, and when the coupon is greater than the YTM, the bond sells for a premium. Okay, I will not do the other calculator. Now, finding the YTM of a semi-annual bond, we didn't do this one in class. So find the YTM of a 10% semi-annual with 30 years. The bond sells for 1,226, which is the same one as this bond, but instead of asking you for the price, I'm asking you for the YTM, which is 8%. Okay, so we know that the bond has, again, 30 years times 2 equals 60 payments. I'm looking for the YTM. The present value is 1,226, and I will use more decimals to be more accurate. Payment is 50 and future value 1,000. Don't forget here, Y50, it is a 10% times 1,000, and then you divide that by 2 equals 50. So N equals 60. Present value negative 1,226.2349. Payment is 50. Future value 1,000. So I% equals 3.999999%, which means 4. Okay, so this equals 4%. But this is a semi-annual bond, so that's 4% semi-annually. So when you do YTMs on a semi-annual coupon bond, you have to multiply the YTM in the calculator by 2, which equals 8%, the same number we had in the bond when I was giving you the YTM and asking you for the price. So be careful with semi-annuals. You have to multiply by 2 the YTM. When you're finding the YTM, multiply the end, divide the payment by 2. When you're looking for the price, you have to divide the YTM. Pay attention. Now, this is in the homework. I didn't cover it in class, but current yield is the coupon payment over the bond's market price. Okay. So we don't use par value in this case. We use the actual bond market price. So let's do this bond. We know that the market price is 1,226, and we know that the coupon payment, and we do this on an annual basis, so it is 100. Do not use 50. Okay. Even for a semi-annual, you use the annual coupon. So it will be equal to coupon payment 100 over the price 1226, and that equals 8.16%. Okay. Now sometimes it may be equal to the YTN. Most of the time it isn't, just because prices fluctuate on a daily basis. But for this bond, the YTM is 8%, the yield to maturity, and the current yield is 8.16%. It's another number that it's good to know when you're investing in bonds. If I pay 1,226, what is my annual yield based on this price? Okay. So you don't have to assume that you're holding this until maturity. The YTM is assuming you hold it for the 10, in this case, 30 years. In this case, you're just finding, if I pay this number and I receive this coupon payment, what is this year my coupon, my current yield? Okay. And lastly, we talked about these tables in class. There are three main rating agencies: Moody's, S&P, and Fitch, and they use this classification. They classify bonds into investment and junk. Junk, these are not speculative. People buy them because you can either make a lot of money or lose a lot of money. In this category, highly speculative, it's even more. It's a gamble. Very risky. Default is you're very unlikely to get your money, but if you do, you can make a lot of money. And if you want to be in a safer investment, then you buy investment grade bonds. The U.S. government is AA+. It used to be AAA, but it just happens that because we do have a lot of that, that's been happening. And lastly, I didn't do this, bond risks. When you invest in a bond, what are your risks? One of them is called default risk. And please find these ones in your PowerPoint, in your book. And that means that you buy a bond, and what is the chance that you will not make your money back because the company goes under, or it stays afloat, but they don't have the money to repay you the coupon payments or the principal. That's what we mean by default risk. Another one is the inflation risk. And as we mentioned in class, if you buy a 30-year bond, 50-year bond, 75-year bond, by the time you get the last coupon payment and the par value, it's been 30, 60, 80 years. So inflation is going to eat up a lot of your purchasing power. So the longer the maturity, the more inflation risk you're going to have. The longer the maturity, the more default risk you're going to have. If you buy a U.S. government 90-day bond, you will make your money back. It's 90 days later. The U.S. government is not going anywhere in 90 days. Now, you buy a 30-year U.S. government bond, even U.S. government debt, 30 years, who knows what may happen in 30 years. So you always have that default potential. And the other one is called interest rate risk. And this one is, what happens when rates go up? Bond prices fall. When rates go down, bond prices go up. So if you buy a bond and rates go up, you will see the price of your bond decline. If you don't want to lose money, you always have the option of waiting until maturity. However, if you buy a 90-day, you can, everyone can wait 90 days. But if you buy a 30-year, then you have to wait 30 years. So again, the longer the maturity, the greater the interest rate risk.